So this video is going to go over second order linear system solutions. So what is a second order linear system? Well, if we have our mass spring system as we've had before, we have our deflection for our spring or our deformation and our velocity for our mass, we can get our equations of motion. So d dot is equal to v, mv dot is equal to negative k times d. And we can simplify this by replacing all the v's with d dot to get md double dot plus kd is equal to 0. And we know that this is linear because there's no d squared, d dot times d, or anything like that. We know it's time invariant because m and k don't change with time. And we know that second order because d double dot exists. We have a second order derivative, or in other words, we have two energy storage devices that are independent, our mass and our spring. So how do we solve this for the homogeneous case where there's no force acting on the system? Well, with a first order system, we would have guessed using the trial solution method that d of t is equal to a1 times e to the a2t. But with the second order system, all we need to do is take that logic and extrapolate on it. So in this case, we're going to guess that d of t is equal to a1 times e to the a2t, just like before, but we're going to add in a second exponential for that second order. So a3 times e to the a4t, both of those exponentials added together. And then we could just follow nearly the same procedure as with a first order system to solve for a1, a2, a3, and a4. Take a derivative of it, plug it into your equation of motion, and then solve using your initial conditions and those parameters that you already have for a1, a2, a3, and a4. And that's how you solve second order linear systems.